My name is WilfordGrimly. Today I'm going to present to you EIP-038 Partial Voting. This is an entry for ErgoHack V. What are we doing? I want to return governance power to miners. So when Ergo launched, traditional mining pool formation was disabled, and its mining algorithm Autolycos had non-enforceable puzzles, meaning that every miner had to solo mine. When Autolycos 2 was introduced to Ergo, it disabled non-outsourceability rather, allowing miners to join traditional pools, helping smaller miners to smooth their rewards out over time. Ergo's governance model was built with the assumption that every miner would be solo mining. Voting takes place over an epoch of 1,024 blocks. Soft forks require 9% supermajority of mine blocks in favor, and parameter changes require 50. Because voting takes place in epochs, miners, and therefore pools, voting in favor of a minority preference are less likely to have their votes counted than their peers. This is censorship at the network level and should be avoided. Non-unanimous traditional pools of miners that wish to hold internal votes still must censor their minority voters, as they are required by the network to submit a vote for or against any given change. So that's what I want to fix. Why is this important? Ergo's basic principles or its social contract from its manifesto say that we should strive to be as decentralized as possible, that any parties, social structures, software developers, and miners should avoid central points of failure, that any actor whose absence will disrupt the system's function need to have contingency planned in the event of a disruption. So as miners, we need to know what we're going to do if pools stop working, let's say. The less pools that are on the network, or the less hash rate spread out between pools, the less secure the network is, especially when, as we just seen, censorship can happen in voting both internally in a pool and on the network if large pools exist and the network is not spread out, the hash rate is not spread out across the network. One other thing that says in the manifesto, right at the top of the basic principles, is that in case of intentional violation of any of these principles, the resulting protocol should not be called Ergo. Meaning that if we know that we could further decentralize and we're not further decentralizing, if we're not being true to the principles, and let's say a fork happens on the network that is more true to those principles, the fork that is true to those principles will be the fork that is called Ergo. So if we want to have the name, we got to make sure that we own up to it. There's two solutions to the vote censorship issue. The first solution requires a fork. So modifications would be made to the node to allow miners to submit a partial vote in favor of proposed changes. This would enable mining pools to relay their miners' internal votes directly to the network to be counted. It avoids the minority censorship problem that comes with voting epochs. Drawback of which being that attempting to pass this change via a soft fork would result in future chain splitting. Therefore, a hard fork is safer. There's a solution that doesn't require a fork, and it's kind of cool. It would use future iteration of smart pools and subpools developed by getblock.io that would enable miners to vote on changes and be directed to a subpool with its own node that matches their voting preference while still benefiting from pool rewards across that entire smart pool. The drawback to this solution is that it's the same minority censorship problem. Because of the 1024 block voting epoch, miners voting in a subpool with a minority preference are less likely to have their votes counted when compared to the fork solution. So the fork solution does a better job of solving the issue. Not to say that we shouldn't also use the no fork solution in tandem, but it doesn't fully solve the problem. The no fork solution can be implemented this way. So we'd use the smart pool and subpool contracts designed by GetBlock, wherein we'd have one smart pool that contains a number of subpools that can change with the following requirements. Okay, the subpools within that system share block rewards with each other using the shared data across all subpools within the system to calculate and pay out subpools and their miners. Each miner in the smart pool, or in each subpool, is awarded a box by their subpool's payment contract that enables them to sign a contract managed by the smart pool with their preferred voting parameters. Each subpool has its own node, bootstrapped by the pool operator's default. Okay, this is cool. The pool operator's default node votes for no changes to the network. When a miner within the system indicates the desire to vote for any changes using the above-mentioned voting contract, their future shares are redirected to a subpool and node matching their respective preference. If no subpools and respective nodes exist within the smart pool matching the miner's preference, a new subpool is created by the smart contract and by the control contract of this smart pool essentially, and a new node is created by the pool operator matching the miner's voting preference. There's a few ways to implement that part. It could be done manually with like a wait and a check kind of thing. It could use containerization like Docker. Could in the future even use some kind of automated system with Flux nodes trading Ergo from the smart contract for Flux, sending it to a particular Flux address, across the bridge to a Flux address that is configured to use a Python script or something to generate a new version of the Ergo node matching the correct parameters, and then spin that up in like a Flux node so that there's some kind of decentralization involved in the system. You can use Amazon Web Services as well. There's a few different ways to do it. All that being said, after confirmation of the first block of a voting epoch, where any potential changes are proposed, subpools and their nodes voting for any changes that are not a proposed change are consolidated back into the default subpool and a node indicating a no vote. So because the way that it works right now, you can only have one soft fork solution and one soft fork and two parameter changes at a time. Once one of those has happened on the network, there's no longer a need for any miners to be voting for anything else. So if their subpool is not already that pool, they're going to be pulled back into the default no vote. We're not going to manufacture any kind of consent for them to say, oh, well, they must support this change because the pool does. No. If the parameter that they were voting for is not the one that is going to be voted on by the network, they're pulled back to the default node, default voting no, and then should they then choose to vote on the parameter changes being proposed by the ones that the network is voting on, they can then join that appropriate subpool that should still exist. It shouldn't be destroyed with the others because it matches the one that's being voted on by the network. By using smart pools to split rewards fairly between subpools managed by their own respective nodes with their own respective voting preferences, not only will all miners within the system see on average the same rewards as they would mining to a traditional pool, but they'll also have the power to vote on changes to the protocol while supporting their sibling pools with different voting preferences. It's like a more democratic pool where the pool can be agnostic. The issue is that while this mitigates traditional internal pool censorship and avoids using a hard fork, it is still bogged down by the same issue wherein we have this minority preference problem where if you're in the minority, even within the smart pool system, and a new pool is spun up, it's going to be less likely that over 1,024 blocks you mine a block. And in fact, it'll even be less likely that the node you left mines a block because you guys have split your hash rate between two different nodes. The other downside is that it increases the hardware overhead for central pool operators to an extent because they have to spin up new nodes. Now, that's not very heavy requirement, but it is a requirement, and it means that smaller central pool operators who may want to enter the scene would have a harder time because they'd have this expectation from miners that they're going to be given governance rights, that they have to have this large hardware overhead to be able to support. So we're left with the fork solution because the no fork solution still has the same censorship issue. In this solution, we introduce new validation logic to the Ergo node such that miners may report partial support for any given change while maintaining all other rules. This change would enable pools of miners to indicate their support for given changes provided their pool operator has a method for tracking their miner preference. This is achieved by changing the Boolean nature of votes to allow a range of potential support and expanding the validation logic to include a collection of data representing the node's support percentage on each proposed change. A new parameter, max voting accuracy, is defined and can be modified by future voting that determines the accuracy with which votes are counted. with a reasonable minimum and steps to mitigate future censorship risk. Currently, miners vote for any particular change and any associated parameters by posting their preference in the block header and extension block, respectively. The hard fork solution will measure a miner's support for any given change using new data provided in the extension section of a miner's block, and then count the total votes as it does now. With a defined range of potential support as defined by our new voting parameter, we can fine-tune a balance of vote accuracy to data cost, enabling us to increase the effective number of decimal places in a pool's vote should the network's hash rate grow to a point that pool censorship is taking place again, and decrease it should the network reach an equilibrium of hash rate across pools such that all miners' votes are being counted accurately, and thus the data cost can be reduced. In the future, this parameter can be used to derive saturation targets for smart pools, but that's a topic for another day. Several parts of the Ergo node must be modified to allow for partial voting. We need a new parameter that miners can vote on to later modify the maximum voting accuracy of pools. This parameter is used in several places to flatten our votes into the 1024 votes of a voting epoch. By including this value, we give miners the power to further increase the accuracy of voting should network and pool hash rate grow to require it to avoid censorship, as well as to decrease the value should the network reach a saturation point with pools of equal hash rates that do not require such a high degree of accuracy, thereby reducing the data cost. The extension section of a miner's block may include additional information regarding the degree of their support in favor of any particular change, measured on a scale with max voting accuracy's current value representing 100% in favor of change. The vote validation logic is modified to include the new data from the extension section. We're going to go over some of these specifics now. So from the voting settings section of the Ergo node settings, we've added parameters to be a requirement for this file. And in the voting settings class, we've added our max voting accuracy as a log. And then when we're defining our soft fork approved and change approved, we've changed it such that votes count and count are divided by our max voting accuracy value. And then we're saying that soft fork is approved if the votes count divided by the max voting accuracy is greater than the voting lengths times soft fork epochs times 9/10. So essentially we're flattening that out so that it's happening over the amount of time that the network has decided is appropriate for the voting length, and the should that be changed in the future, this should all work as it's defined here. Onto the voting data file from the Ergo node view. We're going to modify it to enable our logic. Voting is no longer Boolean. Should be increasing the number of votes. Sorry, I should say voting on behalf of like a miner or a pool is no longer Boolean. So we should not be increasing the number of votes by 1, but by value derived from the extension block. So you'll see here, if vote ID is a vote 4, rather than it used to say votes plus 1, we've changed it to say votes plus extension.vote option as a log. And we've got the same references down here as well. I haven't yet defined this in the extension validation section, so work is going to be needed on this file and a few others. This is another one of them. Where are we here? This is the Ergo state context file in the node view. We changed the value of proposed votes from being counted up by 1, but to be a value of this extension. So you'll notice in this last page, we're looking at the collection here, and here we're looking at the option. So the option is going to be what a miner's actual vote is, or a pool's actual vote is, and the collection is going to essentially be equal to the max voting accuracy, like every integer from like the beginning of it to the end of the max voting accuracy is going to be what our vote collection extension section file is. Moving on to the Ergo state context in the node view. This is another section where I need a little bit of help. Haven't changed anything here, but I speculate that our double votes file is not going to be accurately checking. Like, I don't think this validation step is going to be working at the moment because we're no longer increasing votes by 1. So votes are going to be not just 1, they're going to be much larger numbers now. So I don't believe that this, I think it needs changing. We're into the parameters section. We're just going to add max voting accuracy integer. This is just basically a lot of the stuff in the parameters section is just copying how other parameters are defined and giving it a byte. This is the one exception. Here, the value of max votes must be modified to accommodate our max voting accuracy. A couple sections here that I'm not 100% sure on. Don't know if this needs to be changed or not. I think it can stay as it is. I think this is just for like validating the way that parameters are voted for at the moment. But I want to copy that function for the way that we're going to also count partial votes. Here, we're just making our new parameter tick all the boxes that every other parameter has. So it's got its byte assigned. We're actually missing in this section max voting accuracy maximum, which we do need. Without it, we could run into an issue in the future where we just run out of space and we break the whole network. So we're going to need to define that within like the realm of what can be calculated with the amount of data costs, like the available data we have. As well, Cheese Enthusiast pointed out, these ints should probably be longs because for not much more data costs, we can end up with larger values when we inevitably need them in the future, which would reduce the need for pools that are measuring internal votes to smooth out rewards the higher the value of max voting accuracy. Still some things to do to continue researching no fork solution. Piazza is a tool being built alongside this in the ErgoHack that allows you to run simulations of different potential pools with different potential hash rates, voting different ways on the network and seeing what the results would be. When that's done, I look forward to using that tool to help prove the censorship pool censorship issue I've been talking about. If decentralized smart pools with self-enforced saturation targets become dominant on the network in the future, the need for the EIP can be reduced, and so pursuing that potential proof would be worthwhile. Another thing I want to do is help develop methods for pools to enable their miners to vote. So neither the soft fork or hard fork solution is of much use unless pools have a reliable method of measuring their miners' voting preference in the first place. Succinct non-interactive share proofs, SNIZIPs, are being developed by GetBlock in ErgoHack V right now. It's super cool. There's a paper out for it you should read. They're going to be very useful for counting votes within pools. Need as well to rally support from miners, developers, and pool operators for the change. Finish modifying the node to include all relevant logic, test and have all proposed changes reviewed and audited. And importantly, educate others on the value of decentralized governance. In conclusion, disabling non-outsourceability introduced the ability and necessity for pools to censor a non-unanimous group of miners and an incentive for miners to join pools during voting epochs to have their votes counted. By enabling additional validation logic to count partial votes, we can enable pools to report their miners' votes accurately, mitigate censorship, and return governance power to miners. Thank you very much for your time. Please do have a look at the EIP itself on GitHub, and see you next time.